go. Theorem number 1. In a circle, fill in the blanks. In a circle, a radius that is perpendicular to a chord bisects the chord and its arcs. God bless you. What does bisect mean? Crosses? It does not mean crosses. What does bisect mean? Bisect does not mean perpendicular. Bisect does not mean intersect.
It means to bisect.
Divide it into two congruent parts. It doesn't just cut it. It doesn't just intersect it. It's not necessarily perpendicular. Bisect means cut in half. Cut into two congruent parts. So it's not just intersecting. It's intersecting at its midpoint. It means to intersect at its midpoint. So that means E is the midpoint of AB. Add tick marks to your picture. E is the midpoint of AB. Wait a minute, it bisects the chord, and what else does it bisect? It's arcs. So that means if this arc is a 61-degree arc, then DB is a 61-degree arc. So go ahead and label your picture of my made-up arc angle and measure. 61 degrees. Bisects the chord and its arcs. Oh my goodness, what does converse mean? That's a long time ago. Isn't it like a shoe?
Yeah.
If it is cloudy, then it will rain. What is the converse?
It will rain.
If it's raining, it will not.
If
it's raining, it's
If it's raining, then it's cloudy. And I think, Nasia, you were close to that too. You switch. I never said whether it was true or false. I don't care if it's true or false. Converse just means you switch the hypothesis with the conclusion, whether it's true or false. When does it rain without clouds, by the way? When does it rain without clouds?
sometimes with that clouds.
Where does the rain come from if there's no clouds?
Sometimes it's sunny and it's
Yeah, that's
raining.
true. Sometimes it's like really
I didn't say the
outside
sun
and
was
raining.
not. I didn't say the temperature. I didn't say anything about the temperature. If it's raining, there's clouds. That's where rain comes from.
Don't open the door.
Okay.
Just like, oh my god, hey,
Oh my
you have
gosh.
to be related.
Hey, that's
Oh
not
my gosh. I'm just happy.
All right, so stop. If a radius is perpendicular, then it bisects. What is the converse of that? If it bisects.
If it bisects arcs, it bisects the chord.
If it's perpendicular, look at the green. If it's perpendicular, then it bisects. What is the converse?
If it bisects,
If it bisects, then it's perpendicular. Goodness gracious, end of period. So the converse is also true. If it bisects, then it's perpendicular. Let's draw a picture of that because I don't think y'all know what I'm talking about. So I've got a circle. I've got the center. I'm going to draw a radius because there's a radius in this situation. And then I'm going to draw a chord. There we go. So what I'm telling you is that if you see a picture like that on the test, look at that picture. If that radius is bisecting the chord, what can you add to the picture? If it bisects, then it is perpendicular. So what can you add to that picture? 4 right angles. That's what perpendicular means. It means it intersects at 90 degrees. So if it's perpendicular, then you get to add tick marks. If there are tick marks, then you get to add 90-degree angles. Okay. Next theorem. Chords equidistant from the center are congruent. Matt, what does equidistant mean? Yeah, that's it. It means equal distance.
So if they're congruent, then they're equidistant?
Well, let's see if the converse is true. You think it's true?
Yes.
If they're equidistant, then they're congruent. If they're congruent, then they are equidistant. That makes total sense. Think about it. What is the longest chord in a circle? The longest you can get. Longest chord is the, say it louder. Diameter. The diameter is the longest chord you could possibly draw in a circle. Now, as you inch away from the center, so here's the longest one. Let's say that one's 10. As you inch away from the center, whether you go left or right, do you agree that those chords are getting smaller, 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 smaller? As I inch away, that red, those are smaller than the purple. That one is smaller. As you get further away, you get smaller. But don't you agree that if you inched away the same amount, if I inched away the same amount from the center, that is going to be congruent to that?
Yes.
As you get further away from the center, you get smaller, but you get smaller in the same increments. So, if they're the same distance away, that's this. If they're the same distance away, they're the same length. Alrighty then. We already know this one, but let's remind ourselves of this one. If a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. Oh, you need some notes, Dimitri. Thank you for asking me for the notes when you saw everyone else had notes and you didn't have any notes. It was a really good job of you to ask me for these notes. You're picking at your If a line is tangent, then it is perpendicular. Have I made y'all do this yet? When a radius meets a tangent line, you get a right angle? Oh.
I remember that.
Then I haven't made you do it yet. So, this theorem is saying, when a radius matches up with a tangent line, there is, every time, a right angle. And the reason that I'm stressing this is that, let me show you what you're going to do wrong. Are you ready? Okay. There's a picture. You know, in this picture, that you're supposed to add a box somewhere. There's a 90-degree angle somewhere. And do you know what many students do? They put it right there. Because that's where they're used to seeing the right angle. But that would be incorrect. Because what the theorem says is that when a radius meets a tangent line, you get a right angle. Where's the radius touching the tangent line? Do you see it? Radius, tangent line. That is where the right angle goes. And that's what most people mess up. So, you're going to do it with me? Put your pencil down. Most of you have it down already. Okay. One's going to be your radius, one's going to be your tangent. Ready? I'll say it first, and then y'all can do it with me. When a radius meets a tangent line, you get a right angle. Ready? We're all going to do it. Arms up. When a radius meets a tangent line, you get a right angle. Louder. Julius, Dimitri. Let's go. Ready? Kendall. When a radius meets a tangent line, you get a right angle. Those of you who didn't do it, I hope you put the right angle box in the wrong spot. All right, here we go. Last theorem of the day. Congruent chords intercept congruent arcs. Oh my goodness, what does intercept mean? Other than in the context of football. Oh, I got Dimitri's attention. Whoa, I said the word football. Maybe we should do that more often. Congruent chords intercept congruent arcs. What does that mean?
They cross or something?
So if I said, I'm talking about chord AB. What arc would chord AB intercept? Chord AB. Arc AB. Chord AB intercepts arc AB. It's kind of like saying, hey, which chord makes a crescent? Or it's not I can't call it a semicircle. I don't know what to call that. Pretend it's kind of like a crescent. What chord and arc together would make that shape? A taco. There you go. A taco. So if I said, what arc does chord CB intercept? You would say arc. Brett's paying attention. CB. Turn over to the back. It is example time. Label what you're given. You always label what you're given first. Label what you're given. Label it on your picture. Label it on your picture. Kendall, label what you're given on your picture. That picture should have numbers on it. Kendall's going to go label it on the board because he's refusing to label it on his notes. Go do it. Go label on the circle on the board. Arc GB is 51. AB is congruent to CD. CD is 8. There's some bad notation here. I don't know what teacher went in here and added these symbols, but that should not be there. Excuse me while I fix this. Unlock. Delete. Unlock. Delete. Okay, Kendall, we're ready. Now the figure is correct. The information at the top is correct. A distance can be equal to a distance, but a distance can't be congruent to a distance. So that's why those segments should not have been on top of there. Thank you. So we learned all those theorems on the front. We probably learned them for a reason. We're probably going to need to use some of those theorems. So the first thing that it's asking for is measure of arc AB. Omar, what do you think the measure of arc AB is? It is 102. Whether he knew it or not, whether he guessed or he knew it, he used a theorem. The theorem that he used said, hey, when a radius is perpendicular to a chord, it cuts the arc in half. Well, wait a minute. If that got cut in half, then this arc is 51, and that arc is 51. And then he did arc addition, 51 plus 51, and that's how he got 102. 51 plus 51. All right, Torin, segment FD, how long is it?
Where is that? I can't see
At the bottom.
it.
It's on your paper. 51 is a measure, it's a degree measure. I'm asking for the length. And who is doing these? Who did this? They thought they were helping and
Yeah, that's.
They don't know.
See, it's
Oh.
not helping.
oh, Torin, it would not have made
I
a
know.
difference. Come on.
Oh,
Are those symbols on your notes as well?
yeah.
Those
Yeah.
segments above?
Yeah.
Bad news. Okay. Torin, use this and this to help you.
Oh, it's 8. No?
CD is 8. I would like FD, please.
Oh, so half
4. When a radius is perpendicular to a chord, it cuts the chord in half. So if the chord is 8, then half of the chord is 4. John is not here. Julius, measure of arc CD. 102. Very good. Congruent chords intercept congruent arcs. If arc AB is 102, then arc CD is 102 because their chords are congruent. Last one, Lewis C, AB. So AB is the same length as CD. I want AB. This one. It's not 4. No. AB equals CD and CD is 8. 8. AB is 8. Let's move on.
We, you know how we have the lines? These don't have the arc.
Yeah.
But it has the lines.
Awesome. It had the stuff I didn't want and it didn't have the stuff I needed. Wow. I will fix that today. I'm going to put that on my to-do list. Fix chords lesson. I need to rename it as well to just chords and not chords and tangents. Radius of circle Z is 7. The radius is 7. ZF is 3. And HD is 60 degrees. Oh, that's so cheating. I'm going to fix that too. So, when it says the radius of circle Z is 7, right now there's only one radius drawn. What's the name of that radius? In my picture up here, not in your picture. What radius is drawn? Name it. What?
Oh, it's CHF.
Do we know what a radius is?
Yes.
From the center to the circle. HZ, ZH, HZ. Okay. That is not the one I want to label 7. You have to be sneaky about it.
There's a line already there.
you know that there's a right angle here. You can draw your own radius. You don't have to use the radius they give you, and it was already drawn in your notes, which I didn't realize. You can draw your own radius and label that one 7, which is really important. All right, ZF is 3, and HD is 60. Measure of arc CD, Leah. 120. Very good. When a radius is perpendicular to a chord, it cuts the arc in half. 60-60. That's how she got it. 60-60. Measure of angles CZH. Catherine. Measure of angles CZH.
I said CZL.
Same thing. Same angle. What do you think, Catherine? How much is that angle? So we learned on day 1 that a central angle equals its arc. What arc is it opening up to, that purple angle? Yes, and how much is it? So that angle is 60. Very nice. Austin, CF. Where's your calculator? Good luck square rooting in your head. Go get your calculator. Dimitri, calculator? Paige, Lewis M, Ashley. Megan, how long is CF? 6.3. Nasia, how'd you get that? What did Megan do?
Square root of 60.
Square root of 60? No. She used somebody's theorem. They're kind of famous. Pythagorean theorem. Right triangle. What did she do, Nasia? Is it ringing a bell at all?
Yeah.
Okay. Megan, is that what you did? 7 squared minus 3 squared, and then you took the square root? Perfect. Ask me a question about CF. Now it's time to ask me if you're confused. Kendall, how long is FH? 4. Awesome. Brett, how did Kendall get 4?
Because the radius from Z to H is 7 and ZF is 3. So
Awesome.
7 minus 3 equals 4.
7 minus 3. Are y'all seeing that? Look, they told us the radius is 7. Guys, if this is 7 and this is 3, like if I just gave you a segment and I was like, hey guys, that's 3 and that's 7. Could you find X?
Yeah.
Totally. 7 minus 3. Next one. How many more do we have? 2 more. We can do this. AB is tangent to circle C at point B. Uh-oh. When a radius meets a tangent line, you get a right angle. Everyone needs to add a right angle to the correct spot on their picture. If AC is 25, why did I write 6? Awesome. Find the radius. Omar, which one is the radius? Can you name it with 2 letters? CB. So everyone is looking for CB. Got it, Matt? What'd you get? 20. Oh, we love Pythagorean triples. Thank you for being a Pythagorean triple. Problem number 9. 25 squared minus 15 squared is what Matt did. He got 400. He square rooted 400 and he got 20. Last problem. Given AB is the same exact length as DB, find arc BC. I'll give you a second to think about it. I will tell you what theorem to use, though. The theorem that you're going to use is the one that says congruent chords intercept congruent arcs. Oh. These notes are the messiest notes I've ever seen.
I'm done with this. This is confusing.
Okay, that's fine by me. Okay. Congruent chords intercept congruent arcs. Go. Congruent chords intercept congruent arcs. So this chord, yeah. Nope, not that one. A different chord. A different arc. I said chord and an arc. Julius, what other arc is 100? Name the arc with 2 letters. What arc is 100 besides AB? BD. That's really important. This one matches this one. So I need arc AB. I know it matches arc BD. This is 100. Not BC, BD. And then we do a simple subtraction problem. And what do we get, Torin? How? What is the measure of arc BC? Way less than that. BD is 100 and DC is 20. 100 minus 20.
80. Yeah, I just have to
80.
That's rough.
All right.